Hello folks, well we have got a GT868 as promised, kindly sent in by one of the viewers. We have a Cheiza GT868 or whatever they call it. They call it a CB702, a bit like the Academy ones call them CB701 and CB702. So there will be Cheiza CB701, which will be the 2-knob version using the 858 chassis. So it is Cheiza CB702. We don't have a fuse on there. We're going to need to do something about that. That needs to be off. Put the serial number. It's 151011263. Often the labels on the back have come off. It's come with the Cheiza original microphone. So thank you to the person who kindly sent that in. It's also come with the bracket, and it's got the wrong screws, which is probably a blessing because the right screws are too long. It shouldn't be self-tappers either. The right screws go and clonk one of the cans, and then you end up with no transmit. It was a problem. You put the bracket on as the instruction book said, and you broke the radio. Tell you what, we'll test it as it is. We don't have sockets for those connectors, no idea what that is. See if we can get the crocodile tip. So we've got to put a fuse holder on that anyway. So GT868 chassis, it's a 3.5 watt radio. So if we get 3.5 watt radio out of it, it's fantastic. The service manual says anything over 1.7 watts is acceptable. At least you get a real power meter on these and not a fake one like modern sets. So PA speaker, looks like it goes in that one, and so our test equipment extension speaker will go in that one. So we've got a hiss, so that sounds about right. Let's start by going into PA. Testing 1 2. And on these sets, in public address mode, you have no control over the volume. So it's one of those situations where you'd end up having to use one of those awful power microphones with a little volume thing on for PA, or use an attenuator on the output, which in American terms is known as an L pad. I don't know what they're called other than attenuators here, but they're called L pads in America. I'm looking for my pen, I've already lost it. So, meter lamp works, internal speaker works, microphone works, PA works. Well, that's a start. So we will go into transmit. Let's put picture in picture on. So we're going to be on the 3 watt scale of the test set. So full scale deflection is 3 watts. We'll key it up on channel 20. Oh, we're doing well more than 3 watts. 3.4. That's a good start. And on channel 40, .4. Sorry, channel 20, channel 40, let's go to channel 1. 3.5. You probably notice on most of these we do get a little bit more power on channel 1 than you do on channel 40. It's easy to generate those lower frequencies. That's the thing there. Let's go back to channel 20. Do a low power test. Switch at the back. It's non-adjustable on. Oh dear, that's stiff. It's working now. 250 milliwatts. It's non-adjustable. I've got slide switch mark on my finger now, and the transmit current is only 801 milliamps on full power. Really efficient. So for what it's worth on this test set, we'll look at the deviation. Wow, look, it actually says 2.6. VCO we don't do on this set unless it presents as being faulty. We already know it transmits on channel 1 and 40, so we don't need to delve into that. It isn't a straightforward thing. It's a general purpose synthesizer, and it's a matter of looking at a lock detector pin. So it's not like the little voltage adjustment like you get on sets using the LC7137 chip or even the Toshiba TC9119. Frequency test set's been on for a couple of hours, so what we see is correct. And we have got 2779143. So it's slightly high. That means that sometimes it's been fiddled with because it will have dropped with age over 40 years, which is why I say that. So because of that, we'll now have to set the signal generator to match. So 2779143, otherwise we're going to get an unfair reading if the signal generator is correct and the radio isn't. With 100 microvolts on the radio, and the meter is being very generous. So 100 microvolts is showing on this radio as 22 microvolts. While we're looking at the meter, it's going to transmit. Knowing the radio does 3 watts on transmit, and it's in the centre of the red zone, which is actually correct. I know it says it's kind of calibrated 1, 2, 3, 4, but the service manual says sets to the centre of the red zone, and of course that's only valid into a dummy load. And as I keep saying, you know, I can key up when we're on an aerial and it might bang across. It's still doing whatever watts it's doing, in this case 3.4. It may only just move, doesn't mean it's doing less, it's still doing 3.4 because it's relative to SWR. And I also keep saying that modern sets, it's programmed to read what they want you to see. You can even take the output transistors out of a modern set and it'll still say it's transmitting. Bang! It's transmitting. Switches work, potentiometers work, the sockets work. So let's have a look at the SINAD. So the downfall of the GT868 is it can be too sensitive for its own good. Remember, these are the worst of the bleed-over boxes. It's the same chassis in the Fidelity 1000, but I think they're lovely sets. They're really reliable, great transmitted audio. You can hear the burner brigade on every channel, which is but that's not the radio's fault, is it? So we're in the middle of nowhere. It really doesn't matter, and let's get that up on the screen. One day I'll reset where that camera is. Put a bit more volume on. Remember, the squelch on these radios is AM. Right, so for 12 dB we've got 0.56 microvolts, absolutely fine. For 10 dB we've got 0.48 microvolts. That's the pen on the floor. For 20 dB, if it does it, it is 1.3 microvolts. And I found the pen. Squelch. So I like the squelch to be I like the squelch to be 100 microvolts for it to open. So let's put this on the attenuator, the inset picture, so you can see where we are. We're going to start at, we've got it at 3 microvolts at the moment, so 10, 30, 100. So I'd like the squelch to open at that, it doesn't. 300, 1 millivolt, 300 millivolts, it never opens. That's a clever squelch. By the way, we have our signal generator in EMF mode, not PD. PD is easier to achieve, we do EMF. So I just want everybody to know that who've queried it. Electromotive force and potential difference. Never opens. Let's look at the threshold. So get the set to, I've turned the signal generator to standby, so we've got the red light showing that we set the squelch on the radio to threshold. Signal generator back on. A rather not very good 1.4 microvolts. That isn't good enough, but I'm sure it'll be adjustable, not rather than the fault. So that's gone through it. It's a working set as long as you're very, very careful with the squelch. I'll put the soldering iron on ready because we're bound to have to unsolder the speaker. So the service manual shows a sweep generator method. We've had it on the bench behind using the Quartz Lock 282A test set behind me. We've done that before on this chassis, done it with Fidelity 3000 because that's where the sweep generator lives. We don't normally do CBs on that test set because it doesn't go down to 27 megs on the signal generator, but the transmitter test part of that test set does do, which is why we use the deviation meter on it. So what we're left with here, nice to see original Great branded speaker. It's nice to see the shield plate not missing. We're going to have to open that up and get the frequency adjusted. Why are the tie wraps missing from here? I don't know. So despite these being cheap and relatively not good on receive selectivity, you still have all this decoupling, so you haven't got this hum shenanigans that you do on some oh, it's soldered just there. That is the correct thing to do. So our frequency adjustment is under there. I'll tell you what, we'll do that first, and I'll check it again later when we put the lid back on. So let's go to the frequency counter. And press transmit and see what we have got when we switch the set back on. 2779139. Don't inadvertently do the other one, which is VCO. Good, that's sorted that problem out. So you're getting so high on the way that was, it could just be noticeable. It's not illegally out, but it's just starting to be noticeable. So one of the tips is, if you've got low power, as in less than 1.7 watts, always check this half watt or 1 watt resistor, whatever it is. If you've had a bad SWR, that resistor can fail. I'm looking for sharpness on the back of that socket, and it's absolutely fine because you can lose RF energy there. Yeah, that's fine. So our tune-up starts here and we work up that way. There shouldn't be a coil in that one, and don't adjust that one unless you've got a spectrum analyzer, because it is the second harmonic trap at 54 megs. So it doesn't change the transmit power, it just changes the interference. Of course, if you've got it on a cheap power meter, it will change the transmit power and you won't see the interference. But they transmit, you won't be gaining on 27 megs, you'll be gaining on 54. Why can't I get into that? Is that the wrong tool? Let's use a different one. Must be tolerance. Right, so here goes. We're looking for the centre of the peak. First one done. Very slight improvement on the second one. That was already spot on. Fourth one. Fifth one. That's the coil you knock over if you put the long screw into the case side. Right, let's move over to the next one. Solid 3.5 watts now. There we go. Just make sure this hasn't been twazzled. Just the placement of this coil can make a difference. And we've got 3.6 watts, and that's with it definitely warm. So that's 0.1 more than the manufacturer says it does. So 3.6 watts. So let's look at the other channels. Channel 40, 3.5 watts. Channel 1 is 3.65. Current consumption on channel 20 is now 856 milliamps, and low power, where's the switch? There it is 240 milliwatts. Right, we will look at what the deviation is using the test set behind me. As I've said a few times, the deviation meter needs the capacitors changing on this Marconi test set, and I really can't be bothered to do that. We've got I think we've got 3 or 4 of these test sets, but I'm not changing it and I'm not repairing it, so we will move over to the other test set behind me, the Quartz Lock 282A, which will tell me the truth. Wallow, wallow, it's actually spot on. It's not often that I come to a set that's got spot on deviation. Magic could come back to this a week later and tune it again, couldn't I? I wouldn't. I'd still find something to adjust. Good. So that's that. I'll tell you what. We'll put this cover back on. This solder is to stop microphony. In other words, it transmitting rattle or receiving rattle as you go over bumps. You can end up with that. You can end up with that on business radios. I remember the Tape 500 series could be so rattly if it got loose screws in the VCO that if you got CTCSS it would drop out. Right. So that was just fiddling around the edges. Let's see what the meter says on transmit. Should be sent to the red zone when we're in high power. It's just a little higher sent to the red zone, so we'll drop that. Good. Receive. Already working really well. Again, I'm thinking we'd be dusting around the edges. So they have a funny detector on these sets. Let's put 100 microvolts on the signal generator. And we'll look at the oscilloscope. That looks to me as it should be. Very, very, very small adjustment. So it could come back next week and I'll find something to adjust. So let's see whether there's anything to be got extra out of the receiver. We'll start at the front end. Spot on. Oh, micro something there. Yeah, that's spot on. Put more signal on, we'll look at the IF. Intermediate frequency. seem to have got a little bit there. Possibly a little bit there. Nothing to be had there. There we go. Let's get a new reading for SINAD. Just going to check we're still on frequency-ish. Seven nine one two three, because the lid makes a difference. So for 12 dB SINAD, we've now got 0.47 microvolts. About where we were with the Maxcom 16E the other day. For 10 dB we've got 0.41. For 20 it will now do it under 1. It's now 0.95. So squelch again now. So we're going to turn squelch to full. Let's put the attenuator up on the inset picture. 1, 3, 10, 30. I want it to open to 100. It's not doing. So one of these two is squelch. I think it's that one. It is. So we've just opened there. Back the signal generator. I'll put it back to 100. We're opening. So they've done that. Now we need to check threshold. The signal generator to stand by. It's parked at 0.3 of a microvolt. Let's turn the squelch to threshold. Switch the signal generator back on. 0.75 is absolutely fine. So we've done that. And now it's the S meter. So we'll put 100 microvolts on the test set, and the S meter should read 9, and it reads plus 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 plus. So it's the other one of these presets. We need to drop that. The lowest I can get it is there. So it's still not as it should be. Let's give you a reading. Instead of it being 100 microvolts, it is no, that's not the way to do it. It's 95 microvolts. It's pretty close, isn't it, that? So it's still a little generous. So we are done. That was about right. So it's 2.2 to 2.5 kilohertz. So the deviation adjustment is there, but it's spot on, which is very unusual. So before I put it together, I'll turn the test gear off because we're done, but we'll just put it on the aerial. Roger. No Rogers at the moment. We'll come back to this in about half an hour. I'll go and do something else. Right, so I've put a couple of tie wraps in to put that back to how it once was. I'll just go into transmit from cold. Oh no, we're on the aerial now. Forget that. Let's put this back on. Next week's road trip on Wednesday it's road trip Wednesday, isn't it? Will be to Lowestoft. We're on business there. So we'll take the camcorder along. It's getting regular, this, isn't it? So this radio was so spot on that it's as if it's been serviced. But as I say, we can service a set a week later and still find something to adjust. It's like painting the fourth bridge, isn't it? It's like tuning a church organ. And get to the end of it and think, well, actually that note's slightly out. You could carry on again. So pretty spot on set for a great GT868. We're going around the edges here. We've got the 3.6 watts. Deviation was right. I didn't even need to adjust it. Frequency was slightly high. I've brought it down a bit, and we've gained a tiny bit on receive sensitivity. The only thing really was the squelch and the S meter. But I've probably said before, Mark came to stay one weekend, Mark G7NDJ, and he wanted to call me, knowing that I'd got a CB radio on channel 31. He wanted to call me while I was on my way back from work, and there was no CB set up here as a base station, and he got a key for the property. So he let himself in, and he looked on the shelf and he saw there was a Fidelity 1000, and out of all the sets on the shelf, and there must have been 50, he pulled that set off the shelf, connected it up to power supply and aerial, and called me on it, because he knew that out of all the sets, that was the one that was likely to work out of a pile of untested sets. So there we go. One niner Roger. So we've got squelch. You can see on minimum squelch we've got no hiss because the signal is so low that, remember, I've adjusted this. Some people might not like that, but it would still open. Really quiet. Just to prove it. Oops, it's come on. Quite a lot. There's a really low residual background noise today. Should be a good day for doing this. Right, we'll be doing an on-the-air test. As ever, it didn't speak. So thank you for watching the Cheiza CB702 from 1981, one of the great GT868 radios.